What we're going to do here is we are going to learn about building exponential, logarithmic, and logistic functions, logistic models, and we're going to plug all these things in to our graphing calculator. And so what you want to do, whoa, I don't know what I'm doing. I'm trying to make this go to the side, but then every time I click on this, it disappears. So what you want to do is go to Stat. First, you want to clear this, and so this is the price of Harley-Davidson stock since it went public, and I guess this is the time after year 1 times 0. I guess they don't really put a price in there, okay? And so I guess after 1 year the price was at 0.392. And then after 17 years, it was at, that's 39 cents if you're talking about stock prices. And then after 17 years in 2003, it was at 47.53. So what we're going to do is use a exponential model to look at the growth of Harley-Davidson stock. So let's do that. And the way you do that is going to Stat and Edit. And you guys probably know how to do this. And go up to the top of list 1 if there's stuff in it, and hit clear. And then you arrow down, and everything will clear out. And then you put in all those numbers. Don't put in 0 because you don't have a y value to go with 0. So just go 1 through 17. Okay? Because I did that before, and that didn't work for me. I'm going to pause. So now what you do is you second quit out of there, second quit, and you go to Stat, Calc, got it? And you want to do an exponential regression, so not linear regression, not quadratic regression, not any of those things, not this one here, just so you know, is logarithmic, okay? The next, just because on the test, people did the wrong one when I gave them the test. Number 8 is logistic, right? That's the one that speeds up and then slows down. So we want exponential regression. This is logarithmic regression, which kind of starts fast and then slows down. So exponential starts kind of slow and goes really fast. So I'm going to hit Enter. And then I want to put it right into my y equals, okay? So I'm going to go bars, then I'm going to go to y bars, and I'm going to go to function, and I go to y1, and it should put your exponential regression right in there, okay? And I'm going to hit Enter. And there's my exponential regression, which is y equals 0.47544466 times 1.358 raised to the x. Okay. Now, when you're graphing that, okay, probably you want to set your window so that your years. I set my years from 0 to 20 because this goes from 0 to 17.
You can use Zoom Stat.
You could go Zoom Stat.
Yeah.
Okay. And the other thing, if you want to see the points, you would go second Stat Plot, and you would turn plots on, okay? So it says plots on. If you want to see the points, you have to go there. And now I am going to hit graph. And so we have our equation. Use a scatter plot to graph the data. And then you should get, there's the points. And that's a pretty good fit of those points. But what type of curve do you think would actually be better than exponential regression? Probably not logarithmic, but logistic, right? Because it starts fast and then it appears that it starts to level up, which makes sense for a stock, right? Because eventually you're going to kind of hit some saturation point there. So so that's what it looks like. Graph the equation. Use it to predict. We'll come back to this in a second. Express the equation A equals A0 e to the k at. Graph the equation and use it to predict the price of the stock in 2004. And so 2004 would be year 18, right? So you could go second calc, and you could go value, and you could put in 18 in there. Got it? And if you hit enter, it will tell you that the price of the stock in 2004 should be really, really big, right? Which is probably not right because you're following this exponential curve here, right? But really what the stock probably does is kind of slows down. And exponential stuff, it starts kind of slow, but then it goes up faster and faster. So from here to here, it is more than doubling, right, in 1 year. Even though it starts off not going up by that much, right? And so the value of the stock after in 2004 would be $117.61. And that's, guys in the stock market, they make predictions and they're wrong a lot of times because maybe they're using the wrong function to model stuff. And what does K represent? Oh, we haven't got there yet. So now we have to solve my equation in terms of this. Okay, so I'm going to go to my equation, which is about, I got to get Moby out here, which is about, it says work offline, but it should be connected. How are they connected? Can you see it? It's right on here. There we go. Okay. So I have approximately, my equation looks like or so I'm going to just grab this thing here, and so your equation is approximately y equals 0.475, right? 0.4754. This is what I got from the calculator. And did you get something like this? 1.358 raised to the x power? And you want to change that into a sub 0 e to the kt. Right? And you will have to do this on a test, and it's a little bit tricky. But this is really your initial value. So this and a 0 are the same. Okay? So in your equation, this and this are the same. So I want to solve this. Really what I want to do is want to find out what k is. So you know that this and this cancel out. Okay? Those are your initial values. And then that must mean that 1.358 raised to the x, which instead of x, I'm going to call that, I'm going to call that t, okay? Because that's just your variable. So instead of calling this variable x, I'm going to call it t. And then I know that that's got to be equal to e to the kt. So what does that mean? What does e to the k have to be equal to? Right? See, if I do like this, e to the k has to be equal to 1.358. So 1.358 has to be equal to e to the k. So by taking the natural log of 1.358, I can find out what k is. See that? And so I could actually calculate that. I can put natural log of 1.358, and I could get a number which is 0.306. Did I do that right?
Yeah.
So I get that y to rewrite my equation in that form, a to the 0, even though I cancel it out here, it's still this 0.4754 e to the naturalized 1.358, or about 0.306 t. Okay? And then they ask you a question like, what is the growth rate? Is that what they ask you?
What does K represent?
What does K represent? That represents the growth rate per year, or the percent stock, or percent that the stock goes up per year.
Do we have to write the per year part?
Per year.
Just write the growth rate.
The growth rate. Yeah, I think the growth rate. Okay. And I think that's it. Is that it? Is that all the questions on there? I think that's all the questions on there. Is that all the questions
There's
on
a
there?
logarithmic.
Oh, there's a logarithmic. Oh, now I'm getting algebra
And the
stuff.
logistic ones too.
Yeah, there's a lot. So I'm just going to talk about those. I'm not actually going to do them. Okay? I'm going to hide this. So these are kind of the same thing, and I don't want to go through putting all the data into your calculator. But if I did this one, this is going to give you, let's do that again. This is going to give you a logarithmic model. So if I were going to graph this, notice that with a logarithmic model, these numbers are very big, and these numbers are relatively small. So usually when you have that, you want to use something that's an inverse exponential function. In other words, a logarithmic function. So if you graph this, you will get something that looks kind of like, I think this is a pushed over logarithmic model, but if you model it, it'll look something like that on your graphing calculator. And once again, on your calculator, you're going to use the regression, the one that looks like this. Logarithmic regression, ln x. And then you just kind of do the same thing. Use it. This one you don't have to change anything into anything else. It just says use the regression capabilities of a calculator to fit a log. You can do that. You express the equation, and with this, it actually gives you those letters, so you can just plug it in. Then you graph the equation, predict the height of the balloon, and the atmospheric is 560. You just plug 560 in there, and you'll get it up. Okay, so that's pretty straightforward. I don't want to go through that whole thing. Okay, and then with the logistic model, just make sure you choose the right one. Okay, logistic regression. And in this case, notice that it goes up really fast, and then it kind of starts slowing down. So if you were to graph this one, right, you're going to get something that kind of looks like, it starts off, what is this that we're, biomass in a culture. So with biomass, kind of starts down here and goes up. This is your initial value, right, or the initial amount that you start with at time 0. And then it kind of goes up and it reaches it doesn't do that. It reaches a saturation point, and so you will have an asymptote somewhere up here that it is approaching, and that value will be this C value up here. That's the equation of your asymptote, right? And your horizontal asymptote. And this is your growth rate. This is that's just some constant we decided, right? And then you can do that on your calculator. All right? You got that? Okay, so can I stop my video?
Yeah.
Oh, okay. I'm going to stop it. And I think I'm going to stop recording.